Hello and welcome to Physics with Amol sir. So this video is for class 12 and we will continue with the chapter of moving charges and magnetism. So previously we saw the concept of Lorentz force and we saw what happens when a charged particle moves through a magnetic field. Today we will talk about the concept of velocity selector and we will talk about working of the cyclotron. Okay, so let's begin. First let us talk about the velocity selector. So we can use crossed electric and magnetic fields and they can act as velocity selector. Now first of all, what do we mean by crossed electric and magnetic field? Imagine this red pen, this represents an electric field. So let us imagine we have an electric field that is pointed upwards like this. Okay, so from down to up, this direction is the direction of the electric field. This blue sketch pen, this will denote a magnetic field. Okay, so here we have a magnetic field like this, right? So you can see the electric field and magnetic field, they are making an angle of 90 degree with each other. Both of them are perpendicular. So you can imagine a condition like this, right? The electric field is going from down to up. The magnetic field is going like this. Okay, so as compared to the board, it is coming out from the board and it is perpendicular. And this black sketch pen, this will denote the direction of a charged particle. Okay, so a charged particle is moving like this. Can you understand now? We have red sketch pen, that is the electric field. This blue one, that is the magnetic field, and the black sketch pen, this represents the moving particle. Okay, the charged particle is moving in this direction, right? Let us represent this on the board now. Okay, so here we have, this is the y-axis, this is the x-axis, and this is the z-axis. We had imagined that the electric field is along the y-axis. So this is electric field E. Then we had imagined the magnetic field is along the z-axis. And the charged particle is moving along the x-axis. So let that be the direction of the velocity. Okay. So this is the situation. So these are the crossed electric and magnetic fields. Okay. So we have electric field crossed with the magnetic field. And the charged particle is moving perpendicular to both of them, right? So this is the situation. Now these two fields, they can act as velocity selector. Basically they will do the work that we can actually allow only particles which are having a particular velocity to pass through. The other particles will be deflected by the crossed fields. Let us see how. So you remember the unit vector along the x-axis is given by I cap, along the y-axis is given by j cap, along the z-axis is given by k cap, right? So therefore we can denote the electric field E as E y cap, and we can denote magnetic field B as B k cap, and the velocity can be denoted by vector V I cap. Okay, so this is the vector denotions of all the three vectors. Let us find the forces on the charged particle. Let Q be the charged particle that is moving along the x-axis. The electric force Fe on that charged particle is given by Q into vector E, or we can write it as Q E y cap, equation number 1, right? Then the magnetic force Fb on that charged particle will be given by Q into vector V cross vector B, right? So we can write it as Q into V I cap cross B K cap, equation number 2. Now we can write equation number 2 as Fb equal to Q V I cap cross B K cap equal to Q, this V B will come out and I will get I cross K, I cap cross K cap, and I but minus J cap. So I will get minus Q V B J cap, minus sign. So this is the magnetic force. Let us call this equation number 3. Therefore, the total force, that is the Lorentz force on that particle, is given by F is equal to Fe plus Fb Then from equations 1 and equation 3, we can write F E we know is equal to Q E J cap, and we found out this is equal to minus Q V B J cap, right? So we can write this as equal to, Q will come out of the bracket and we'll get this as E minus VB J cap, right? This is the total force that is acting on that particle Q, which is moving along the x-axis. Now this equation, let us call this equation number 4. This equation will give the total force that is acting on this particle. You can see the direction of forces along the J, that is in the along the y-axis. Okay. Now this term, this gives the magnitude of that force, that is Q into E minus VB. We can adjust the values of E and V such that they will cancel each other out. E minus VB will cancel each other out, so that this force will become 0. Okay, let us see how. So the magnitude of that force is given by Q into E minus VB, right? If we adjust it such that this F becomes 0, then we can write Q into E, we can write E is equal to VB, or we can get V is equal to E upon B. For this velocity, we will see that both this force, the total force acting on that particle is 0. If that happens, the particle will move without any deviation. So we can actually select such particles which by adjusting the ratio of electric field to the magnetic field, right? So if we adjust these such that the particle moves without any deviation, we can actually select the particles which are moving. So such kind of velocity selectors are actually used to find out the ratio of E by M. Okay, so we can actually select which particle is allowed to go through. So that is how crossed fields are used as velocity selectors. Next, we will see a very important topic, and that is the cyclotron. Now, a cyclotron is a type of a particle accelerator, right? What does a cyclotron do? It can accelerate charged particles with very high velocity. Okay, so if we put a charged particle inside a cyclotron, it can actually increase the velocity, let us say up to 70%, 80% of velocity of light. So we can actually have a large velocity given to a particle, and that is the purpose of a cyclotron. Okay, now of course you will ask, why do we need such high velocities? Well, basically scientists have managed to create something called as collider, particle accelerators, particle colliders. You must have heard of the LHC, the Large Hadron Collider. Okay, now there are institutes such as CERN, CERN, okay, which have very large particle accelerators. The function of these is to accelerate the particle with a very high velocity. So sometimes this can be used to collide the particles. So if two particles collide with each other with very high velocities, we can actually break the particles. Okay, and then that enables us to find out what these particles are made up of. Okay, so sometimes to find out elementary particles, the accelerators are used. Also, they can be used if you want to diffuse ions into particular materials. Okay, so there are numerous uses of particle accelerators, and as I said, cyclotron is a type of a particular accelerator. Now, let us see the working of a cyclotron. First, let us talk about the principle of a cyclotron. I am sure you remember when we spoke about a charged particle moving perpendicular to a magnetic field. Okay, we discussed that when a particle is moving perpendicular to a magnetic field, it will move in a circular path, and the path is such that the angular frequency is given by QB upon M. So we see that the angular frequency is independent of the radius of the path, and it is independent of the energy, right? So the angular frequency, because it is independent, no matter how much the radius, it will always have the same angular frequency. So this particular principle is the principle of the cyclotron, right? So what we do in the cyclotron, we accelerate the particles such that, okay, the radius goes on increasing for the same kind of frequency. Okay, so now let us see the construction of a cyclotron. A cyclotron looks something like this. So you will see that in the center there are two discs. Okay, they are called as Ds. They are actually hollow metal discs. Okay, two discs are there on their D shape. Therefore, they are called as Ds. Let us call them D1 and D2. these are connected to an AC power supply. Okay, AC is supplied so that we can change the polarity of D1 and D2, and they are placed in a very strong magnetic field. Okay, so that is the basic construction of a cyclotron. Okay, so this is the diagram that you will be drawing in the exam. We have got these two Ds. Let us call them D1 and D2. Okay, these are hollow metal discs. They are placed in a magnetic field, and these Ds on the external side, they are connected to an AC power supply. Okay, so this is the basic construction of a cyclotron. On D2 you will see here we have a deflection plate that finally we will use for deflecting the particle outside. Okay, now let us see how a particle accelerator works. What we do, we put a proton at the center. Okay, now you will see that there is already an AC power supply given. Let us imagine in the first cycle, D1 has a positive charge and D1 has a negative charge, that is negative polarity. Okay, so and already the magnetic field is exerted. So of course we have crossed electric and magnetic fields. Okay, this is the magnetic field that is coming outside of the board. The electric field is between the D1 and D2. So you will see, because this is positive right now, electric field is like this. Okay, it is moving from D1 to D2, right? So if you put a positively charged particle, okay, let us say a proton has been put in the center. What will happen is, because of the electric field here, this proton will get accelerated towards D2. Okay, the force on the proton will be in this direction. So the proton moves inside the disk D2. Now, what will happen? Inside this the D2, there is no electric field. Why there is no electric field? Because of the phenomena of electrostatic shielding that you must again be remembering. So inside there is no electric field, but inside the disk we still have the magnetic field, right? So the proton is moving in a direction that is perpendicular to the magnetic field. Because of that, the proton will start moving in a circular path. So the proton moves like this, right? So it moves and it comes here. Now we adjust this AC frequency such that by the time the proton has come halfway over here, the polarity is going to change. So what will happen? By the time the proton comes here, D1 becomes negative and D2 becomes positive. And that is some adjustment that we can do very easily. Okay, AC frequency that can be adjusted, right? So we adjust it such that the half time that it takes. So if T is the total time period for one revolution, by T by 2, the frequency has changed, right? So when it comes here now, D1 has become negative. So what will happen? The proton will now move inside D1. Again there will be electrostatic shielding, and due to the perpendicular magnetic field, the proton will now move in a circular path. Okay, by the time it comes here, again the same thing will happen. But what is interesting is, when it is doing the second turn inside D1, you will see the radius has increased. The radius increases because the proton gets energy, okay, by a factor of Q multiplied by V. V is the potential difference between the plates, right? So the proton acquires energy, due to that there is increase in the radius. But as I said, the principle of cyclotron is very simple, that the angular frequency or the frequency of revolution does not depend upon the energy. So it still moves with the same frequency. So thereby what will happen? There is actually an increase in the velocity of that particle. So by the time it comes here, it has actually increased in radius, increased in its velocity. And again it does this. So by the time it is taking around in D2, there is again an increase in the radius. By the time it comes here, again there is increase in the radius and the velocity. So by the time it has completed the round, okay, when it has got a radius equal to the radius of the D's, it achieves a very high velocity. When it does that, there is a deflection plate over here. That deflection plate is able to deflect the charged particle outside. When it comes out, it has got a very high velocity. Sometimes even 70%, 80% the velocity of light. Okay, so very high velocity can be attained by using the cyclotron. Okay, the complete working and all the steps of the cyclotron you will find in the notes that I have provided to you. Okay, now we will see how we can find the frequency of the cyclotron. Okay, the cyclotron frequency. So for that, I hope you remember we have found that omega is equal to QB upon M. This is the angular frequency. Keep this in mind. Let us call this equation 1 for the time being. Now, if capital T is the time period, that is the time taken for the particle to complete one revolution, one complete revolution, we can write T is equal to 2 pi by omega. Correct? And from equation 1, therefore, this becomes 2 pi into M upon QB. Okay, this gives the time period for one complete revolution. Let us call this equation number 2. Now, if nu is the frequency, don't confuse with this the velocity. This is the frequency of revolution. So, if nu is the frequency, we can write nu is equal to 1 by t, and therefore from equation 2 you can write nu is equal to QB upon 2 pi m. So you will see the frequency of revolution depends upon these factors. It does not depend on the energy of that particle. It depends upon Q, B, and mass of the particle, right? So it is independent of all the other factors. So this is the frequency with which the particle is moving. Okay, and it is also called as the nu, that is cyclotron frequency. Okay, next we will see how we will find the kinetic energy of the charged particles when they come out of the cyclotron. For that, I hope you remember the relation. The velocity of the particle is given by V is equal to QB R upon M. Again, this is the same relation that we did when charged particle was moving in a magnetic field. Okay, so the kinetic energy of the particle will be given by half mv square. So using this relation, you can get it as equal to Q square B square R square upon 2 times M. So this gives the kinetic energy of the particle when it is coming out of the cyclotron. Okay, so these two concepts, that is the velocity selector and cyclotron, very important from exam point of view. Make sure that you understand the concept properly. Go through it in the textbook as well. Okay, so it's a very interesting concept. If you can find out more on the internet about cyclotrons and about particle accelerators. Now there are some very large particle accelerators in the world. In fact, they are so large that they actually normally accelerators, they are constructed underground because they need a very large radius, correct? So that the larger they are, the better work we can do, right? So find out more about accelerators. I'm sure you will find them very interesting. So that's all for now. Go to the textbook. If there are any doubts, make sure you are asking. Okay, thank you.